Oh, hello everyone. Today, our topic will be I think start from housekeeping. So all the content recorded from last week have been uploaded and sorry, all the contents have been uploaded here. So you basically can use a link to see the previous video. And Daoshan have shared with us two links. I have read them before actually. So they actually share with you about how a PhD student goes through their career, not just about the findings you get, the exciting result you have, but also the emotion part. Like how could you survive in this very long journey? And if you are interested to take a PhD program later, you probably can read this first to understand what will happen when you have a PhD degree and to just foresee what will happen to you to get prepared. So that's that one. So today we were talking about is this writing tools, Latex, Overleaf, and the reference management in the code. I think Tim already have a very good tutorial, I think last week or the week before last week about the latex. But this one, what we're trying to describe here is first is how you use the latex, just the general guys. And then is the overleaf, which is how should you use the overleaf. And then is practical guides about when you're doing these owner projects or even the projects later, how could you be able to write your proposals, your literature review, and your thesis. Well, the same thing will apply to the PhD students. Like you need to write your research proposal, and then you need to draft several papers. And before was you probably do a literature review or a survey, and then it's about how to do the reference management. In the end, it's if you aiming to have a PhD degree later, take a PhD program, this honor project probably you need to aiming for one or two publications. Then if you aiming for that, how should you prepare all the content and what's the normal process to get your paper published? So this is a rough guideline about what we will talk today. We will start with Latex. What is Latex? I think Tim have described that. Basically, why we're using it is because Latex is a markdown language, and you just focus on the content rather than the style, because not everyone is good at with design and formatting things. For example, myself, I'm not really good at that. I only good at probably writing the code. But if you wanted to have a consistent output of the documents and the papers for people to review, what's really important is your content, right? So you should be able to just focus on content rather than other things. That's basically the idea behind the LaTeX. It is a markdown language. It's not the word processor. It's separate the content from the formatting. That's why it's getting popular and starting very beginning. And also one of the killer feature it has and everyone happy with is it can do the LaTeX with very complex mathematical expressions. Like if you're trying to use a word to do LaTeX things, it's very hard. Like when you're trying to insert a formula in the word, you potentially will spend quite a while and still struggling with where should I put this like a text subgrid or something like that. Then LaTeX is definitely the way you need to solve your problem. And it is actually the standard for the academic and scientific publications. So the advantage is we just actually already talked about that. And another two advantage is it is free, it is open source, it's cross-platform. That's kind of is older times. In the new times, because we have the tools and the platform like the Overleaf, is even more more advantage here. You just open a browser and you open a link and you can start to writing your paper. What it's used for basically is we will start to get it used for our papers, and you can use it definitely later for your thesis and dissertations. Like in theory, you still can use Word to draft your thesis or dissertations for this unit, but I don't recommend you that. I think I caught what Tim said, like even 10 meters away, if you see a PDF produced by the Word, you can see the differences from it with the ones produced by the Latex. Latex one is much, much better. And if you want to write the books or the technical documents or do the presentations, even the slides, you can also use Latex to do that. This is a specific one called Beamer. Or if you want to write later CVs and the mathematical contents, you can also use that, because actually online there is so many templates you can borrow. So you just use like download a like template or open template in Overleaf. You can start writing with very beautiful like outlook of your content. And the comparison between the Latex and Word, one of the key differences is Word is what you see, is what you get, but the Latex is not. Latex needs to do the rendering, and it separate the content and the style. I think that's what we just keep continuously like telling you. And because it's code, so you can basically use Git to do the version control, or actually the Overleaf itself already give you that functionality. So if you one day you delete the whole content in one part, and then next day you regretted, how could you get that content back? It's easy and simple. You just reverse back to that commit. Very easy. And for very, very large documents like the book, if you want to manage all the books very easily, you definitely need different chapters, different files just for specific content. And organize so many like contents together in the Word, probably the scoring is already take you so many time, but Latex can easily get that done. So you can separate it into different files and get it work. So just in case later you probably will be a very famous author or book writer. And learn about the Latex. Teams one already give you very good guideline. I see that slides give you a very good guideline about how could you start with the documents and how could you add the mathematical formula, the figures, tables. But this one, this Overleaf tutorial is good places to start with and do some practice. So it gives some like information background about what's the Latex and why we need to do it, as what we discussed before. And to start with it, you basically have a file, something like this. You start with your document classes. Different classes, for example, if it's a Beamer, then it will means you will have a landscape style of the presentation slides. And content will start from these beginning documents. This one can be able to render something like this here. And then if you want to have different types of the letters in the Word, you probably need to set that up when you do the print. But here is different. You can just declare that in these document classes. For example, here is like your font size is 12, and then you want this paper looks like a letter paper, or if you want it to be an A4 paper, that's all definable. And if you want to draw some very beautiful diagram or do some styling with your tables or with your figures, for example, you want the background color to be a specific one, you can use specific packages, like the Python packages, you can import it. How it's being imported in the Latex is using the package. And then you probably will have some metadata information, like what's the title of your documents and what's the author of it, and when you write this down. You can declare it in these document classes underneath that, and then you starting with a begin document and make the title, you get it something like this. So you declare some content like this, you get something like this. That's basically what it's saying. So you can see, I think there is a footnote or something here, older, which declared by this. And you can add the comments. Comments won't be able to render later in your content, but it can be a very good ways for you to write some comments, say this part of what I want to write down. So organize your own content. And you can also do some styling here, like the bold underlines. So they will always start with different commands. For example, here, this one is bold together with Alex. And then you want to get it stronger, like you have a lot of different commands you can use. This part, like a content, is being rendering something like this. And later you probably want to include some images. Images can be added by this package called include graphics. This one here is being rendered something like this. But if you want to add the image in, you need to actually put the image file somewhere. But if it's Overleaf, you just upload it to a folder. And when you're trying to get the figure be included, there are several commands you need to take care of. First is, like this one is a proper way to do the figure, like adding for the content. So you begin with a block called a figure, and you want to get everything to be centering, and you included these files in, and the length of it should take 75% of the whole text line, and you wanted to give it a caption. So the caption only give the content of the caption. You don't need to specify whether it's figure 1 or figure 2, because the system, when it's trying to compile the whole content into a PDF, they were decided based on your declaratory language. They were decided where this image goes and the sequence of different figures. Then they will assign an order to it. For example, if you have two figures here and due to some alignment things, the figure was being adjusted. So you add another figure in, you don't need to like you doing the word. You go back to the word, you say this is figure 1, then later you add a figure before the figure 1. You need to change the figure 1 to figure 2. In Latex, you don't need to do that. The system will automatically do it for you. All you need to do is give it a caption, and the caption should be put for the figures is underneath this real figure inclusion command. But for the tables, we prefer the caption actually is on top of the table. So you should start with the caption of the table, then you start in your tables content. And then remember, for every figures, all the tables, all the formulas, if you want to reference it later, always put a label for it. Because if you put a label for it here, then later you can put a reference there. So this will be rendered, say, as you can see in figure, then reference to this figure, it will automatically assign this one, get you linked with this one. This is why this one was very powerful. So the downstream explanation here is just what I just trying to explain to you. And you can use a unordered list to render something like this, or the ordered list render something like 1, 2, 3, 4. You also can do some mathematical formula here. So mathematical formula, a lot of ways to include that. This is one way. You start with a $sign, you end with a $sign. It will be render something like this one here. You can also do it in this block way, like begin the mass, end the mass. It will also be rendered something like this. Or you wanted to do it a bit differently, you can also use this slash, like escape character. It also will be rendered like all these several different commands that in the end, they actually render the same thing. It's just based on the Latex engine you are using. You can try to tweaks how you use that. And for the equations and the formulas, you actually also probably, one way is like you just declare it. You don't really need to reference back to it in your content later. But if you do want to reference back to it later, you start with like this begin equation and end equation. It will assign a like 1, 2, 3, 4, and you give it a label here. Then later, when you're trying to in your description, you say it as we said in the equation, and then you can reference back to your label. It will automatically do that for you. And this is one of the complex ways like how this Latex can help you generate very complex like mathematical formulas. If you don't I know it looks very scary when I was first starting it also looks very scary, but you don't need to, because we have these large language models nowadays. For example, if I wanted to, I don't know what's the Latex code for this file, this figure, this formula, and I want to write one. You can basically ask the cloud, say, can you give me the Latex code? Normally, because it's formal language to formal language, you can see it's actually generated that for you, and it's quite accurate. You can starting from there and copy it to your Latex document and starting to tweak that if it's not meeting your requirements. But this kind of coding large language models is definitely your body when you're trying to write all of these things. It will help you improve your efficiency. and get things done quicker. And if you want to get a more complex like equations, you can use specific package like this one to get it declared. So I probably won't spend too much time here. Like I don't think for us we need a very, very complex formula when we trying to write our paper. It's normally quite a general one. But if you do encounter with very complex one, you potentially can like borrow ideas from other papers, get a screenshot and use a Cloudy to generate the Latex for you. And then you paste it in the Overleaf and to see what it's rendered to. If it's not correct, then you fix the problem and update it, get it fit into what you want. And this is the similar like a demo about how should you do the like a mathematical formula. And then next thing is document structure. For us, when we're trying to write a paper, we need to do it with a way. Abstract normally is your overall summary of your documents, of your all contributions. You need to get someone just to read the abstract, can understand what are you trying to do and what's your contribution. And you can, there is a specific block command called the abstract. It will be rendered this way specifically. And then later you can have different types of the sections. The highest level, I think, is part of the chapter. Both of them will be used later if you want to write a like a doctor thesis, dissertation thesis. But if you're trying to write an honor thesis, you actually don't need to do that because for you, you probably only have like 6 sections, and that's limited. You don't need to get it that complex. So normally the command you will use is this section, subsection, paragraph, and subparagraph. Like the command here will be the friend of you. So you can try to align your content more structured as a document structure. And for the table, it's the same thing. If you want to insert the table, this is the ways like how you declare the tables, and you can see each series content will be something like this. And you can do more, like the HTML, you can do more complex, like structure things and layout alignment things. For example, you declare like you need to double of this like a border. You can do all the things of that. And you probably want to get a background of this table and the background give it another color. Like when you're trying to do this, you can start with a command like given here. But if you want to do more complex things and you don't really know where to start with, before the large language models, we normally search on the Google and check the Stack Overflow, how other people doing that. But with this large language model area, you can just give it a screenshot of the basement of the table Latex content and ask the large language model as what I have asked here. Ask it to generate one of the Latex for you and put it in the Overleaf and render it. It should work very quick, very easy. And as I say, like we actually prefer to put the table caption on top normally, but I don't think it's limited, but normally we should do it that way. And the same as the figures, you give it a label so you can reference the back later. And like what happened in the Word, you probably want to add the table of content. That's a specific command you can use in the Word to insert that. Same thing happened here in the Latex. You just needed to add a specific command here. And because you have all these sections, subsections, subsection, paragraph, and subparagraph things being declared there in specific like anchors, this table of content will read that and compile it. So you will be able to directly get a table of content with which page it is automatically, and looks definitely will be very good. And you can try to explore what's the packages you want to use. For example, if you want to draw a diagram, next week we will have some like gurus help us to explain how we use the Latex to draw beautiful diagrams. But the geometry and the tick will be the packages you can use to draw the diagram things. So that's basically the general. If you read this one and trying to do some practice, you basically get the base concept of how to use Latex with your writing and starting from there. And always remember trying to use the large language models, especially the Cloudy. I don't think ChatGPT can as good as Cloudy to do these like code generation things. They are the best on the market. And to learn how to use that one wisely. And the next thing is for the Latex, because it's need an engine to do the compile. So it's doesn't like the word, what you see is what you get. You do need to go through an engine to do the compile. There are actually several different engines on the market. Most common one is this one, and this is a normal, the one we are using. And if you have some script, for example, I want to do a animation or do some very complex things in my slices, I probably use this one. I will give you guys demos later. And if you want to write it, for example, I'm from China, so probably I want to write it in Chinese. The PDF Latex won't be able to support that because it doesn't have like the multi-linguistic Unicode like supported. So you probably need to change your engine to this one. But normally what we were handling is this, and this, these three ones. You normally start with this one in here in Australia, trying to write the paper. If you hit some errors or problems, you can change the engines. It's actually very easy when you're trying to change the engines. It's just in the overleaf is here. You just need to select which engine you want to use and then click it and do the recompile. That's it. So this is a summary about like in which conditions which engine you will need to use. So generally PDF Latex. And if you want to write some Chinese or other languages, use this one. And if you want to do some like presentations or do complex things, try this one because it's actually start with this name Lua. Lua is a scripting language, trying to do some scripting complex things. Then the next thing is we have talked about so many things about the basic language, like how you do it in the LaTeX, then how we start it. In the older times, you need to install the LaTeX program in your local, for example, something here. And then you probably type a command to do the compile like what you have done with C or C++. You need to mark do the compile and then you get the PDF. Then you open the PDF, confirm you are doing the right thing. So in the older times, when you're trying to write with the LaTeX, you normally just see the code and you need to run the command, compile it, and then get the result. And then open it, see it. If there is something wrong, you can go back to change it again and redo it. So it will be time consuming and very, very frustrating. That's why this kind of overleaf was pop up. If you have a web browser opened like application and you write something here and you click the compile, it will render the things like immediately and you see the result. If it's wrong, you edit it. Then that's basically the idea of the overleaf. And this is the interface of the early. I'm not sure whether you guys already started using that or not. But the left side is where you can manage all your files. And the assets in the middle is what's your work area. You should write all of your content here. And this part is where you see the rendered result to see whether what you write there is correct or not. And the benefits of it, we just like described it. You don't need to install anything. You open the browser here, and you can start to use it. And if you change anything, it will not like automatically compile it for you. And if you want to take the PDF out, you just click a button, you get it. That's one thing. And so no local installation, no real-time like real-time rendering. And the other things it will benefit a lot of people is you can share it with your colleagues. So your colleagues can see it, and then if you open the like they can work together with you like the Word, help you edit your like documents or essays. If you get this like tracking open, you write something, it will document what other people have changed. For example, if your supervisor was trying to help you craft your paper, they probably write something there. However, sometimes your supervisor probably don't fully understand what you actually done in this experiment. They probably do the wrong assumption. So they can do this and write it down. You can select, you reject it, or you accept it. And in this way, it can give you better learning experience. Say, okay, I can learn from my supervisor or my PhD peers or owner peers. Say, how should I draft and write my paper better? So this is one of the very good features. I think you will benefit from it later, especially when you're trying to submit a paper for a conference or for a journal. and ready to use template. Like nobody wants to start from the scratch, right? When we're trying to start from scratch, your templates will be very, very simple. Like your content will be want to be that comprehensive. But if you have a template, for example, we have built a template here. We write the pretty complex code here. This is a slice, like a Beamer slice code. And all you need to do if you want to use a template is you just include this slice template in and trying to starting from what we have put there, then you get this. See, you don't need to write too much things. You just download this code, put it on in your Overleaf, and you start to change your content. Like I do a great job, right? And then you render it, you get this directly. It will give you a lot of functionalities. For example, this one can give you the hyperlink with like you can go to different pages and you have different like how many like pages I'm on and where I'm at. There is a lot of templates like this. This is the one we specifically was designed for our group or for you to use. But there is a lot of Overleaf templates you can just open and use it. So let's search Overleaf. You can see like it can be journal articles, it can be books. Or if you wanted to like build your CV or resume, you want to get a very beautiful resume, like look at this. You can just open it and that's yours. And it will render it. And on the left part, you just need to change the name to yours. And it will be rendered differently in here. So you can see there are so many options. For example, this one I just changed it, but it haven't taken into places. So you can go there. There is so many different templates there you can borrow from, like the books, the journal articles. And if you want to submit the papers for a specific conference, they normally will provide they definitely will provide the Latex template for you. All you need to do is copy the content from your honor disease dissertations and then paste it into that proper places of the template. And that's it. Normally you don't, if everything goes well, you don't need to change any content. But normally, all you need to change is change to make sure it meets the page limitation, and that's all. So it will save a huge amount of time later downstream. So that's the last benefits of the Overleaf. And practical guidelines. So for owner projects, I also do the owner probably 3 years ago, I think. Don't really remember that clear. But for the owner, my understanding is you have actually 3 main outputs from the paper based. The first one is a project proposal. I think it's due last week or beginning of this week, right? But that's not really need to evaluate it or it's not assessed. The project proposal is just to get you have like a clear starting point to say what's the direction you want to explore. So you need to identify your goal and the knowledge gap and develop an initial research direction you need to explore later. And then you do the need review as what we discussed last week by Dao Chang and Sri. So you need to, based on your initial research direction and understand, trying to locate the papers and trying to use the papers, build your own understanding in this direction, located this kind of research gap. And then you will have more specific goals and more defining a clear scope of what you were doing in your honor projects or in your PhD projects. You go back to update your project proposal into a better shape, more followable or more practical format. Then you starting to plan your experiment, design your experiment, and plan what's your methodology, what's your contribution, and do that. In the end, you will report your experiment results and how you do it in the thesis. You need to document your findings and conclusions. For the honors, it's more like a research exercise. So honor degree doesn't really require you to have very good findings. You can just explore several areas and find, oh, this is not something good in this direction. I do something wrong. That's a lesson other people can learn. So you don't really have too much expectations, high expectations with honor degree. If you do a pretty good planning all the thesis in the end, with not much contribution in that area, is still fine. But you need to have a very good plan of how you do it and make sure you presented your work clearly. So that's a practice. But for the PhDs, you need to have something better than others. You need to explore the boundaries. So that's a different part of the thesis. And for you guys, if you want to do a PhD later, you probably need to aim in for what's a PhD want to do, like do some contributions, do some findings. But like bear in mind, if you feel stressed in your honor degree, like now or when it's reaching the end, don't need to be too panic. Like you're you you just this is a research practice. You just need to practice all of the activities you will do later in your PhD degree or in your life when you have a job. So the bottom line of this honor degree is also very low, but make sure you do every steps very well. So that's my general guide about how should you do that. And then I think we discussed about the template. I tried to wrap it up and develop some of the templates for you guys to borrow ideas. You don't need to do exactly the same as what I provided because it's just my perspective. For example, the research proposal, you probably put your name, your title, your supervisor or something there. And in the introduction, you have a general introduction. And the problem statement, you say what's the general problem you're trying to solve. And then you list some of the objectives you want to achieve. So you at least have some where to start with. And then based on your initial understanding, what's your methodology. Later, you come back to update these two when you have a clear scoop from the literature. And you declare, because it's a project based. When I first started my PhD degree or my honor degree, I also don't really understand why the research will be a project. Because I'm from the industry, so from our understanding is project more like something you have a plan. And if you do follow the plan, you will definitely get the result you planned. That's what my understanding of a project. But here in the research is the project plan is you have a roughly plan, but research is uncertain. So in the end of the project, you probably won't be able to get what's your planned result is, but that doesn't matter. Like that's actually confused me a lot when I'm doing my honor. But here is like you at least need to plan where about what's the direction you will explore. If everything goes well, you will get that result. If not, doesn't matter. Like that's research, right? You probably will find something else interested during the journey. So that's why we call it project. So you will always need to state your expected outcome here, but don't worry about that too much if you cannot reach that goal because the path is changing, like what like Professor Wu was said in the first workshop. Like some of the very good findings actually are the side effects in your journey, and you need to list the resources here about what you need to complete your honor project. When I was trying to writing that, I don't really understand that. Like it's so obvious why I need to write that down. This is actually right down here. Like currently, I understand it. This is right down there for you to understand whether you have enough resources to complete your project. For example, do you have enough time? Do you have enough GPU resources? Do you have enough data? Or do you need to do something like what's the resources you need? Even the paper is resources, right? You need to write that down and your supervisors or other teams can know whether it's achievable or not. If not achievable, you probably need to tweak it. That's why the a research proposal is meaningful. It helps us to identify the problem. And then is timeline. The timeline itself can be a draft one, so you will always keep yourself in a planned work towards a planned goal. So it's normally started with like a neat review and then design your experiment and try different ways and get the result collected and then do the analyze, then wrap a paper. Normally that's a sequence of your work, but you need to allocate it a different time for you. And it depends on your subsequent projects, you need to change it based on your scenario. So that's a research proposal. And for the literature review, I think last week, Dao Chang was discussed how should you do the literature review. Like, before we discuss this, I think like if you guys want to do a PhD later, the publication always will be good. And for your honor degree, like normally you can probably publish one if you have good findings in the end. So you just convert your thesis into a paper and then submit it to some venues and probably get it accepted a lot later. We will talk about it, like how we do that in this section later. But if you aiming for something more, you want to get yourself more computable, actually the literature review is also publishable. Like what Dao Chang said last week, it can be published as a survey paper. And what will make a good survey paper is your distinct perspective and how you organize these kind of different papers in this direction and trying to view how other people doing this and that and find the research gap, give the coming people better insights what they should do. So if you can do very good things in this literature review, you can also wrap the literature review, publish it as a survey paper if your like a literature review reach that standard. So for the literature review, the general like a structure we recommended, this get some ideas from Garrison Gao, like also like the team behind it, like Wei and Dao Chang. So basically, you can aiming for it as a survey. You have a research fair, and you can like what you do is you read the history paper and trying to organize this, and then support the research gap and looking for the future direction. In the abstraction, you basically summarize it like this: how many papers you have reviewed, how could you do this, and then like what's a different perspective you view for this research direction. And then in the introduction, you basically list the background and the motivation and your scope and the survey methodology, like how could you do the, like what's your research question, how you search and get the literature, what's your inclusion of the paper strategy, what's the exclusion, like some bad papers, you probably just ignore it. And you're filtering it, then you get a list of the papers, right? Then you have a table, and then you have some basic terminology in the second section. See, like these are the basic. For example, if you're trying to do some review with the transformers, like and its variants, then you probably say, okay, this is transformer, this is deep learning, this is something. Some basic terminologies in this second like section. And then you get the people who read it to understand the context in this area. And then in the third part is what's the dimension, how you analyze all these papers. For example, you view this dimension, the transformer papers from dataset perspective, what's the dataset they are aiming for? From task perspective, what's the task they are aiming for? From the parameter size perspective, how large it is? And from the architecture perspective, like what's their architecture is. This you can find a different perspective to summarize them and compare all these papers, trying to support like which way, which dimension of the direction actually works, which will not. So in this way, you actually build your knowledge, and then these insights can guide you to do the experiment later. That's basically why you do this like a literature review and why people writing the survey paper. And then in the content later is you in different dimensions of the perspective, you're starting with a section to detailedly discussing that. That's basically the structure later in here, like how many papers doing this way, what's your result or something like that. And in the end, you do some research gap identification and the recommendation of the future directions. If you cannot reach a survey level quality of the paper, but you still need to reach these status. Like you need to identify the research gap and have a rough idea about how should you design your experiment and design your methodology and contribute for this research direction. That's your focus of this honor degree, and that's where the most marks were from, because that's holds 80% of all your marks in the honor final results, right? So this template is a guideline about how can you, if you're aiming for publish your literature review as a survey paper, how could you like structure it? just to borrow some idea from there. You don't really need to totally follow that. You will see a lot of survey papers when doing the review. You can borrow some ideas from theirs. And then is a final thesis. Final thesis is actually a very big concept. We probably say your final paper, your final output. So final output actually is pretty standardized format. This is a template that was actually being published from engineering school. Some students are trying to download it and adapt it to fit for our purpose. So you can have a logo and you have a projector where it looks good. You can acknowledge your supervisors. But the general structure of your final paper or thesis, it will normally start with the introduction and the background of why you do this, same as what you write in your proposal or the literature review, but it will be more logical connected, more thoroughly. And then is the literature review. Here, the literature review will be much shorter. You only need to mention the things to be able to understand what you are doing in this paper. So some key concepts. You don't need to do, like, you don't really need to copy the whole literature review from your second assignments to here. It's normally just the basic discussion about how other people solve this specific problem you are trying to solve, and how they do that. What's their limitation? To introduce this research gap and to prove that what you are doing actually is meaningful. And then is the methodology. Methodology is your design, your model, how you tackle this problem. It can be a framework, it can be a different architecture of the model, or it can be a pipeline, but it will be your core contribution and a general solution described here as a methodology. It will be different from so in the methodology part, you normally shouldn't discuss your dataset because it should be a general solution. That's why we do the research. We are not an engineer here. So, and then later, when you're trying to design the experiment, you need to compare with a baseline. So the baseline we're established from your literature review is like how other people handle the same problem. You identify some baseline methodologies, how other people do it. Then when you design your experiment, you will need to say, that's my data set. I use the first way, which is the literature, the baseline way, or the literature state of art way to do it. And that's the result. And for myself, when I was doing that, I use the same dataset. I use the methodology I mentioned previous, and I get some result. And we need to compare the result to prove we are doing better. So you also need to mention your metrics, how to evaluate here in the experiment design. And then you will have a table of the results in the result section. Then you can report it. Normally, you will see something in like a standardized paper, like in CV or the NLP is. They will have a very long table. They will say this is historically how other people doing that within this dataset to solve this problem. What's their F1 score? What's their like a hit at one, or what's their MRR? Different areas will have different evaluation metrics. You need to find one for your area and put that as a metric, and it normally goes better. It can be higher or lower, but it normally goes better. And your one should be the best if you want to publish that one. But that's the normal case, but that's not necessary to be the must you need to take. But the result itself is just a table. Then from the result, what you will find out is a thing actually core to to your contribution. You need to discuss why you're doing this actually is correct, doing the better results, and what's your findings, how your results can benefit the future research, which is a future research direction you will mention later. And in the end, you will have a conclusion, say, summarizedly, I solved this problem in this way, and compared to others, I achieved these better results to say, oh, my research methodology is better. So this lighting the coming future researchers can try this way, and this way. And my limitation is I haven't handled this problem and that problem, probably not practical here and there. So in the conclusion, you will do a pretty thoroughly discussion there, but it shouldn't be long. It should be very short. So that's basically the normally what's the structure of your final disease, and then is a reference. But reference normally is automatically generated. And appendix, if you have some like a experiment result, very long one, or your algorithm or something won't be able to fit into the main content of your paper, then you put it in the appendix. And for some papers, like when you submit it to the, because when you submit it to a conference or a journal, they normally have a page limitation. So you want to be able to fit all of the content in your content, in your main content. So sometimes you will put them like not that important things or expense contents in the appendix. And some of the revenues probably says the reviewers must read your appendix. Some of it says reviewers don't have the obligation to read your appendix. Just when they have some like questions with your content, they probably look in your appendix to seeking for more evidence. That's basically how it's being used for. So you can see I have actually write some description down here about what in each part, what you write. So this is actually a standardized like a template when you're trying to write your paper and submit it to a venue. This is how you should follow. So, and when you finish that, and later in the end of it, you will have 10 points is doing the seminar, which is you need to present your work orally with some audience like under it and trying to convince them you are doing the greater things. What's your findings? They may have some problems for you. So you can make a PPT PowerPoint for that. You can also use this template and structure it in this ways, trying to describe what you have found out with more figures, diagrams, tables in here. So that's basically the trick. The link I have shared in the slides, you can, if you want to borrow that, you can just open that link and copy it to your Overleaf, and that's it. So this is about the template and how should we draft it. And some of the tricks is like in your papers, don't put too much content inside it. Like always start with a diagram, an overview diagram, a beautiful one if you can do that. I cannot do that, but like normally a good paper get a high chance to be accepted is a very good diagram to show your contribution. And then, for example, I think I can show you guys some papers we are doing, but I don't think it's a very good example. We just to show you how it looks like. So you can see like this won't be a very good diagram, but normally you have a diagram. So when you see the whole contents here, you don't really want to go into the like the contents you're trying to read it when you as a reviewer, right? That's a human. We are human. To be honest, we don't really want to read too much things. We always go to the figures to have a brief idea about what this paper was trying to do. So a very good summary diagram can give you a lot of attractions and bonus marks from the very beginning. And then you should have tables. For example, this version of the paper actually being rejected because you can see here, I don't have any tables to show my results. When the reviewers go to your paper, the first thing they will check is a diagram, as we just saying, and then they will go to your results section to check the like a table to see what the table was reporting and whether your result is good enough or not. Normally, you must have these two things in your paper. That's normally where the reviewer is starting with. And then if your paper, your methodology is mathematically intensive, or even it's not, but it can be formally described with mathematical things. In computer science area, we prefer that. So in your methodology area, make sure if you can, that's basically why in our section we have a problem like a formalization section. If you can describe your problem and your methodology in mathematical format, like So that will make your methodology more formal and looks more professional. This will get more chance to be accepted as like a paper. That's just the tricks. For example, here we actually attempted to do that. Here it says like this graph will contains the head, relation, tier, and the relation and the tier. These kind of things can be tables and the figures. You can use like a one sentence to describe that, right? But if you put it as a formula, it looks very professional. That's normally the third places where the reviewers will look and trying to understand what you are doing. So tables, formula, figures, spend more effort there. Get your whole content, like get that to be filled probably first, and then start writing the content. From that, then your paper will looks much better. And then is a reference. So I think last week, Sri gave you guys about how should you do the reference management with some tools. And why we needed that, because every day you read a lot of papers, you put it in the contents. And if you're trying to insert the reference in the Word, then you probably will spend a half day or one day just doing that and getting all of the reference aligned. So this is reference to one, is reference to, but Latex can get that out of box. All you need to do is, if you want to reference this paper, export their bib file and then put it in here, in this bib file. And then you cite it in your content. For example, here, you want to cite it. You just cite it, and then you will get it being the citation will be there, and you have this number. For example, this one, this citation format is you have this name and which year it is, and we'll put it in the end as this citation format. And different journals or different papers will have different ways required, like which format of citation you are. You don't really have that much time to just tweak the formats. All you need to do is in the bib style, you change the style of it. That's it, and that's done. So that's why you need to use Latex to do these citation things. And this is normally what inside of the bib file. And if you want to get that, normally you do is like, for example, in this archive, you can just export it, and that's it. You can just copy it and put it in your bib file, and later you can cite it from this name. And this is like telling you like how should you use some like bib text packages, and you actually have different ways to do the citation. You can just cite it like what we have done. The key is the name here. You cite it, and then in the formatting, it will do the standard way like this, as what you just seen here. But if you just want to show the author, for example, you say this guy doing this work, you can also use citation author command. Or you want to do some comparisons with different algorithm in your table, and you want to citation to say this is this year's work, so you can present some like trendings in the literature, how people are tackling this problem. You can do this citation year, and there are two different ways to do the citation. Normally we actually use the first one. The second one is more powerful. You can do more like comprehensive citation. You need to do it based on your template and the venue where you're trying to submit to. Do the decision which one you will use. But left and side, for example, most of the papers you submit to the IEEE, you will use this style. If you submit it to some like good venues like the KDE or WWW, you probably use the ACM one. For you guys to submit the final like thesis and research proposals, I don't think team have set any like restrictions about which citation style you should be, but the template will have it. And yeah, this is tools I think Sri already mentioned last time. This is the one actually we prefer to use. It's very easy to use. And for the online resources, I think Sri also show that how you use Google Scholar to do the citation. It's actually very simple. And for example, I want to cite this temporal graph things. You're trying to find the paper, and you can see here is the button of the citation. You wanted to use a bib text, you just click this button here. and then you copy it. You put it in your, where is my reference? Where's my template? Too many tags. Here. So you just copy it to your bib file. And you do a citation. That's it. It's very simple and straightforward. So that's just a guideline about how should you use it. That's basically the same as what I demonstrated you to do. And there are some best practices you should do. So for example, here, this one, it's actually follow a pattern. This is author's surname probably, and year, and the first keywords of the paper. So they use that to construct a key for this article. So later when you cite it in your paper, you basically know what you are citing and which year it is. It's more meaningful. That's just a programming trick. And you should have a master bib file to do that. And if you like, the third trick is you need to include the complete information there. Like the citation itself, it actually have a lot of like titles, URLs. But for some of it, is if it's a prop publication file, for example, that's the paper I'm working on. So you can see here, it's been published to a like a proper journal. It will have the title, author, which journal it is, which volume it is, which number it is, pages, years, and what's the publisher. So normally trying to fill all of them. If you actually copy it from this kind of their publication page, then you should have all of this. But normally you should check that. That's one of the problems you normally will like have probably. And use the reference management tools, I have said that, and back up your bib file. But if you're using the Overleaf, you don't really need to worry too much about that. And sometimes if your citation is wrong because you put the wrong key there, then you have a question mark. Remember, solve that. That's if you have this kind of things in your paper, that's where show you pretty like a junior guy. So your paper probably will be rejected just because of this. And check the proper commands, and if it's wrong, check the like compile logs error. For example, here, this is actually a good example. My doclin, this doclin file here is actually missing the institution. So they actually are looking for institution keywords in this bib file to solve this problem. So you should normally check this part, this like this bottom here in your overviews to see what's the problem being shown up here, and make sure you don't have any error here, and as less as a warning here. And yeah, that's basically about reference. In the last part, that's the last section we will discuss, is how could you compile and submit your paper to a venue and trying to get your paper published if you want to do a PhD. So the first thing you need to do is you need to identify where you want to publish to. You need to decide whether you're trying to publish to a journal or a conference. For us as a computer science student specifically, I'm not sure why, but my supervisor wanted me always publish to the conference because in the AI area, probably 2 months later, everything changed. So everything moves very fast pace. So the conference, good part of the conference is they are all top conference. If you submit the paper there, they will have a very clear deadline. You must submit it before that day. And then they also have a very clear deadline for the reviewers. So reviewers must give the result before that day. And then they have a set day, your like of the conference date. That's the date your publication will be like on the record. So in this way, you can always get your contributions being delivered to this like literature as soon as possible, because everything in the computer science and AI area moving very fast. But for the area like electrical engineering, like chemistry, or like other domains, journal normally will be more formal publication venue. You need to like identify the like a high like Q1 or Q2 like a high venues of the journals and trying to do that. But the journal in our specific area or in general area, they have a problem is the journal will normally have longer review time. Sometimes it's 1 year, sometimes your paper will be reviewed in half a year. In the computer science area, after half a year,
everything changed, right? What you have done in half a year ago, no, currently everyone probably already done that, or everyone was knowing that is wrong. So that's basically why we target ourselves as computer science people to like prefer the conference rather than the journals. And which will be the like a conference suitable for you? It will depends on your topic. And for example, I think there are some AI. There are some tools online. You can check the data lines. I think this this is not updating anymore. Let's see whether we have updating one. So you can see here, this is actually AI conference data, and some like a community people was doing that. You need to, for example, the LIPS is the very top end top conference, and this top conference is kind of algorithm focused. And for the CV one, like the ECCV or like a CVPR, that's kind of computer vision venues. For the NLP, it's normally ACL, EMLP, or this kind of different conference, like in different areas. For the like if it's software engineering, it's probably the conference called CHI, like this one. And for the security have its own like top ending conferences. So you need to identify what's the direction area you are working on and trying to understand the conference ranking there. For example, in Australia, you're actually using this core rank to identify whether your conference level is. For example, the EMLP is our natural language areas conference. When you search it, you can see here, it's A-star conference, which means they are the best one. And they are the hardest one to being accepted. And so if you think your quality of the paper is very high, you can try to aiming for that. And for example, ACL is also the top conference. You can see the ACL is A-star and the EACL is A. But this one, I'm not sure, I actually haven't heard about that. You can see it's C. C means it's probably not that good a conference. And that not good conference doesn't mean that's not a fit for you. If your like contribution is not that level, but you actually do something and you want to publish it, you can also try the B and C. That's also meaningful. And for the journal, it's actually using different ways to do the ranking. Like the better one is probably Q1. You normally target it for that, and you have Q2, Q3. But this will specific to your area. You need to like determine which one you want to submit to based on time. For example, if you have finished your honor and ideally if you have a very good result, it's normally the end of this year. Then if you want to get your result published as soon as possible, you're probably only looking for the venues have the deadline near that time. So that's where we limit your choice. So you need to check at that time. Also, you need to check the acceptance rates. The high ranked venues typically have a lower acceptance rates, but that doesn't mean they have less papers get accepted. For example, last year, I think NIPS have 10,000 papers being submitted, and they accepted probably 2,000 one. EMLP have 8,000 papers submitted. In the main function, they accepted 1,000, and in the findings, they accepted 1,000. So in summary, probably accept rate is 23, 25, but that's an indicator. Like you need to evaluate like is your quality of the paper actually meet the standard of that conference and feed into the topic of that conference and decide one. Check their deadline and start to writing it. When you start writing it, you need to go to check their older guidelines. For example, IEEE definitely have the older guidelines. See, this is IEEE's general older guidelines. They will give you the Latex or Word templates. You can see they accept both. But before you, like after you located the venue you're trying to publish, always check these older guides. Or for example, the conference, it will have a core for paper page. For example, the AFR 2025. You can see they have the core section, and they have the main conference paper. They have the instruction about how should you write the paper, when you should commit it, and what's the topic they are aiming for, and also what's the spatial streams, and also like how many pages it is, and whether it's double-blinded or like a single-blinded. They have the long paper. The limitation is 8 pages. Short paper is 4 pages. And it's double-blinded means you cannot leak any your personal information there, just to make sure people are not cheating. And how you do the citation, whether your reference section count into these 8 pages, they all have the clear instruction here. So the second step after you figure out where you want to submit to, go to check the other guidelines or the core of the paper. Then next thing is you need to check the important dates. For the papers, like some of the papers, you basically have some, like this AC year is a pretty like a special one because they have like annual rolling review section. It's like every year they have 5 or 6 different conferences, but they're trying to get everyone can submit their paper every 2 months, and then you can decide which venue you goes to. But for other papers, like for example the Triple W, which were held this year in Sydney, I think it's held in Paris 7 years ago. You can see like their important days. For example, in the research track, they will tell you when they will do the abstract. After you submit the abstract, it's just some like descriptions about what you're trying to do in your paper. It doesn't need to be the final version. So they can understand how many papers are actually aiming for their venue this year. So that's the first deadline. And then before this date, you can edit any times of the paper. So that's a 4 paper deadline. And then you can see the review. They have a rebuttal section is this date, and between these 2 dates, actually for the reviewers they have their deadline for the reviewers, and then they will notify you in this day to say whether your paper is accepted or not. If it's accepted, you need to take consideration with the reviewers' comments and change it, and then submit your camera ready. Why is your core camera ready? Is because that's the final version of your paper we're showing up in the venues and in the literature. Other people, when they check your papers, that's a final version. It's called a camera ready version. You must submit your final one at that day so they can make sure your paper will showing up in that venue. So you need to understand and the whole process and the timeline and the importance. Make sure not missing anyone. And the double-blinded, if it's double-blinded, most conferences are double-blinded. If it's double-blinded, make sure you don't leak anything, include the GitHub link. If you put your GitHub link in the paper, that's also be considered as a violation of this policy. You will be desk rejected. It means your paper won't be assigned any reviewers. It's just rejected. And then is you will download the templates and don't modify the template settings. For example, some of the templates, for example, when I was trying to write my paper, that's actually the problem I'm currently facing. Where's my paper? Oh, this one. For example, I feel like I don't have enough spaces. I want to like squeeze something in. You can see there's still a very big space here, right? You can actually do some commands, tricks, like these spaces, get this space being disappeared and trying to get it up. So you can have more spaces to write some more contents. But don't do that because the template itself already been set. You must follow their guidelines. Otherwise, in the final like camera ready section, the editor will figure that out and ask you go back to change your content. So don't do that. And then you also need to learn the template features. Some of it, have some spatial environments for the algorithms and the series. For example, we just showing you like if you want to put your equations in the Latex, you actually have 4 different ways, even more, right? Different templates actually only allow you use probably similar a specific way because their compile environment is being set. So you need to understand what's the limitation, and if your code, your Latex content is being copied to there and doesn't work, then you need to adapt to that. Make sure it works in that specific template. And then is your manuscript. We don't call it a paper, it's called manuscript. after it's been published, it's called a paper. So typically the structure people expected is abstraction, introduction, related work, methodologies, results, and discussion and conclusion, like we showed before. And pay attention mainly to the figures, tables, and equations. That's where we attract a lot of people. And make sure you stick to the page limitations, abstraction names, and the character limitations. Don't do anything violent their policies, because otherwise you definitely will be death rejection. And then the reference style is actually already been set there. Like this one I was working on is an ACR paper. So you can see they give you a template and how you do the bibliographic. You just need to include the bib file and everything is done, because in the very top of it, I actually say I want to use a package ACR and it will render in this double column way. That's it. All you need to focus is in between of it, what you need to write there. And also ensure you cite all the references and make it consistent. That's normally it will be, but do the double check. And then in the final check before the submission, you need to do the proofreading. You normally have several co-authors, your supervisors, check for the spelling and the grammars, make sure your whole description, your storyline is consistent, make your figures, tables are clear to read. That's another tricky do have taught me. When you're trying to include image figures in your paper, make sure you use it in a PDF format, because normally PDF format is vector format. Vector format means if you do something like this, it can be very, very clear. But if it's just a screenshot image, for example, I actually have one I had to do the screenshot. This one here. This is a screenshot. You put it in the PNG. When you're trying to do, it will be something like this. It will have the pixels. So if you can export your diagrams as a vectorized image, like the PDF or SVG, make sure you do that, because that's where normally nowadays people are reading your papers with like a computer. If it's very small, it's done like all times they were printed out. If it's very smaller, you basically can do something like this. Like you can see here, the difference is this text is actually vector. So you can see it's kind of clear, but this image actually is pixel. So you can see it's getting worse and worse when it's getting bigger. So that's one of the tricks pay attention to. And yeah, the double blind review, just to make sure you don't do anything. So normally if it's double blind, it's here for the order section, we will comment out. And your submission content, you can see there will be nothing there. And your submission will just be this plain text, of these documents, PDFs. And so when you're trying to submit your paper, you just submit the PDF when you're trying to do the review section. And also always ask for your colleagues for the feedback, like technically, or clarify of your paper, or get them to read your paper from a reviewer perspective, because it's all peer reviewed. Actually, the guy who decided whether your paper is accepted or not probably will be another student in another university, and that's it. They probably have the same tech level or a research career level as you. Some of it you probably get it as a very a senior professor read it, but some of it is just a fresh a PhD student reading your paper. So it's called peer reviewed. So you will get some opinions from your PhD peers or your honor peers or your supervisor to see what's the problem other people will attack you, whether you have some flaws in your experiment design or your discussion haven't cover all the content it should be. These kind of questions. Make sure you address all of these concerns in your paper before you submit it. This will increase your chance to get your publication accepted. And then in the submission process, normally there are several things like a easy chair. Depends on what's the system they are using to manage the paper submission. The popular ones are Easy Chair, CMT, and recently a very popular one is this Open Review. So you can see here, you need to create an account. And after you create an account, you need to put your profile in, like which university you are, who are your supervisors, and how many papers you publish, who are your co-authors, these kind of things. And this is Open Reviewer, and CMT is kind of another venues like people are using, and easy share. So when you identify the venue, you basically, where's my Open Review? They will give you a link to do the submission. For example, here, if it's active venue open for the submission, like this one, you open it, you can click and do a submission, fill all of the contents here, and then put your authors here, put the keywords and confirm it. In the end, you will include your PDF file and do a submission, and that's it. That's basically in the Open Review how you do that. Similar things will happen for the CMT and others. Like you identify the venue, and if you can edit it will be editable. And same thing happen for the easy share. It's just a different system. You need to make sure you create an account and follow their link and go there to create a submission. For example, this one, create a submission, which venue you want in, and you continue, you submit your files here, and follow the instruction like other system online. And normally what you need to do is you need to put your profile there, because your profile will determine your conflict of interest reviewers. For example, they want to assign a reviewer in University of Western Australia for you when you submit a paper in any venues, because that potentially will be someone you know. So that will be misconduct. This is for that purpose. And also they will gather the required metadata, for example, the title, the abstraction, and the keywords. So in the background, the committee can use that to decide who will be your reviewer, and your affiliations, your other authors, and also your research topics. This kind of metadata is just used for decide who are your reviewers. And other people, when they're trying to bid for reviewing this paper, they can based on that to understand what you are doing. And then is your manuscript, which is a PDF file, and supplementary materials, if allowed. Sometimes they will allow you to submit a package file or video or something. Like journal, probably you need a cover letter, but for us, we basically always aiming for the conferences. And then after you submit it, you basically get a paper ID. For example, I think, let's see this one here. I'm not sure how it works actually, but you will see the number. This is IGCI, which is a top conference this year. This is your ID. This normally will means there are 6,000 papers actually being submitted when you create your papers profile. It could be more because it's very popular like a venue. And you will also be able to track your status in the system. For example, these two are both under the review, so you don't really have any results now. But if you have the results back, for example, this one actually have the results back, you normally have reject. This is a rejected paper. Normally, most of the paper will be rejected, to be honest. People just want to get their paper in and get a, this is not our honor students' work. So you can see they will reject it, but it's not just to click a button and say rejected. They will give you some comments, say which part doing good, which part doing bad, and why they reject it, and what's their overall recommendation. For example, it says clearly below it. This one says clearly below it, but this one says borderline. So it's probably will accepted if like there is not enough paper to be accepted. For example, this one actually is better, so you see more exceptions. Like this is submission. Review is here. So you can see this. I think they have one accept, 1 week rejected, 1 week accepted, and another rejection. So it's 50-50. So it will go to the meta reviewer. Meta reviewer do the final decision, say, okay, you probably go to another stream, get this published. So this is another honor people, honor students we guided last year. And if it's accepted, like this one, yeah, if it's accepted, you can see these are the you still get some reject or weak reject, weak accept, weak reject, strong accept, weak reject, weak accept. So like overall, if your papers, like most people's own opinion is accept, you have a high chance when it's going to the meta reviewer, it will be accepted, and they will give you the comments. But what you need to do is they will give you the comments. Some of the venues will also give you time to do the rebuttal, which means the reviewer will say some questions about your paper, and potentially they don't really have a good understanding with your paper. You want to address their concerns, say, okay, I solved this problem or not. So that's basically most of the papers in the open review, they actually have that. So you have the rebuttal stage. I think I have a paper rejected last year in KDD. I have the rebuttal section. I can show you guys. So in the rebuttal section is that's not the final decision your reviewer made. You still can use the evidence or some code or some figures trying to convince your reviewer that what you are doing is great, so they can change their their comments. For example, this is the initial comments from the reviewer. They say the good part and weak part, and then we do the rebuttal, and then the reviewer will need to go back to see what's your explanation is good enough or not to decide whether they change this kind of ratings, whether your local detect quality will be higher or lower. And after this, you will have your final scores for your paper reviewing, and then some meta reviewer will go there to based on the reviewer's feedback to decide your paper will be accepted or not. So for example, this paper actually get rejected in the final because most of the comments not good enough. And we learn from the comments actually. So we decided to split it into two papers. And one paper is just focusing on dataset, and another is focusing on the algorithm. And we actually, based on the reviewer's comments, edit it. And for now, it's been accepted to the triple W. So don't see the reviewers' comments as elective impact. There always be another opinion help you to get your work to be better. And there is another thing will happen in the reviewing stage because everyone wants to get published and graduated. So there will be bad things happen. For example, I have a very dodgy reviewer haven't actually checked my paper in I think this is the one. This reviewer actually haven't checked the paper. They just want to get their paper to be accepted. So they will just put some very bad things and general elective comments there and give you a low mark to make sure you don't competing with them. For example, this reviewer actually haven't read our paper. He copied some comments from somewhere else and put it there. That's dodgy things happen, and you don't really have too many ways to stop that from happening. Like the system is improving, but to bear in mind, if that happens to you, it's normal. Don't to be too upset. Like that's life we need to live with. And then it's the response to the editor or the chair commission. That's normally happen when it's a journal. Journals a process is in the end you probably get a accept with major revision, accept with minor revision, or reject. Normally, if it's with a major revision, you need to based on the reviewer and editor's opinion to change your paper accordingly, or add more experiments and report the results probably. But if it's accepted with revision, normally means it's accepted for the journal, then you need to promptly to change it and get your paper accepted and published probably. And then that's the last section is you need to handle with the decisions. If it's accepted, good. You need to prepare the camera ready version, address the reviewer comments. And if it's a conference, then you probably need to prepare for the conference to do the presentation. You will see your colleagues, other researchers there in the conference. If it's revised and resubmit like the journal, you need to do the address the comments and trying to revise and submit to the same journal. If it's rejection, then don't worry about that. That's our normal life. Last week, I think Dao Chang is actually a very, very good researcher. He get a lot of top conference exceptions already. But as he said last week, he get 10 rejections before one paper get accepted. So that's normal life for us. So if you get a rejection, it's fine. Don't give up. Just trying to either improve it or trying to find another venue to publish it if you get some dodgy reviewers. So that's it for today. I will put all the materials we mentioned today online. And do we have any questions here and online? Yeah. Yeah, PDF normally is vectorized. For example, I can give you an example. Like I'm not good at the diagram like drawing. I definitely trying to find someone do it good for you. But I use this tool to do the diagram drawing. You don't need to follow the same way, but normally in the end of it, you have some similar functionalities you're trying to exploit, right? Export your final output of the diagram. You have basically, no matter which software, you basically have two options. One option is export as image. Another option is export as PDF. PDF basically means it's vectorized. So it's kind of some SVG format in the background. So it will make sure your diagram, no matter how many times it's being like zoomed in, is still clear. Yeah. Does that address your concern? Okay. Any question online or any other questions? Any question online? If not, we probably finish today's section. And next section will be how to draw a diagram in Latex, and probably other tools we were trying to figure out. We have one pretty good diagram designer and drawer next week to help you with that. Okay, thank you for everyone online and here. That's it for today.